In stimulation single fiber EMG, the stimulus is used as a point of reference to measure the stimulus potential latency for jitter calculation. Current EMG equipment also allows the operator to measure jitter between any two potentials in the signal. This makes it possible to study some theoretical differences between the jitter values recorded during volitional and stimulation activation. This could also be useful to do, for example, when it's suspected that two potentials in a signal arise from a split fiber. This video will demonstrate the difference in jitter for volitional and stimulation EMG. The recording is from a frontalis muscle. There are several time lock potentials in this signal. For analysis purposes, we'll use potentials labeled 1 and 2. The jitter between the stimulus and potential 1 is 11 microseconds. The jitter in potential 2 is 12 microseconds. These jitter values reflect the neuromuscular transmission in the individual end plates. When the jitter is measured between potentials 1 and 2, it is 17 microseconds. Note that this is higher than the jitter in either of these two end plates. This value reflects the combined jitter between the two action potentials, which is what is measured between pairs of potentials during volitional activation. If the combined jitter is abnormal, we cannot tell which of the two end plates is abnormal or if both are abnormal. Note also that the jitter between the two individual end plates is not the sum of the jitter in the two end plates. The jitter between a pair of end plates can be obtained by the formula shown here. We add the square of the jitter from each end plate and then take the square root of the sum to estimate the jitter for the pair. In this example, the estimated jitter from the formula is 16.3 microseconds. This is in close agreement with the measured value of 17 microseconds. In summary, the jitter value obtained during the volitional method is higher because it represents the combined neuromuscular variability in two end plates. If one measures 20 volitional jitter values, they represent a study of 40 end plates. In contrast, each jitter value in the stimulation method represents a single end plate. Thus, theoretically, it would take 40 jitter values in a muscle with the stimulation method to be equivalent to 20 measurements in a volitional jitter study. In practice, at least 30 measurements should be made during a stimulation jitter study. To appreciate the relationship between the reference values for volitional and stimulation jitter, consider the situation in which the jitter values of the two motor end plates are the same. This formula shows that the combined value in that situation is the square root of 2, that is 1.4, times larger than that of the individual jitter value. That is why the reference values for volitional jitter are 1.4 times higher than for stimulation sfemg. Details about jitter calculations can be found in Chapter 6 of the Single Fiber EMG book.